let's work some problems using alternating series tests and see if we can't figure out the convergence and divergence of some series. So the first case, I have negative 1 to the n plus 1 over n plus 2. So what I want to do here is I want to say, okay, I've got this negative 1, this alternating negative 1 term. So what we do is we kind of factor that out. So we'll write that as n equals 1 to infinity of negative 1 to the n plus 1 times 1 over n plus 2. So that way we kind of have it over to the side. Then what we can do is say, okay, well, I identify this as my sequence an. So I need to satisfy three properties. I need to say, is this true? Is the sequence always positive? Well, yeah, because if I keep plugging positive numbers in there, it's going to stay positive. So yes. The second one, is it decreasing? If I do n plus 1, is it less than the nth term? So we can kind of say, yeah, well, clearly, because each time you add n, it's going to go lower. But if we wanted to be more, if we want to be more strict with it, we need to do a couple of things. Or there's two ways we could do it. One is we could set up some sort of function, f of n, or f of x equals 1 over x plus 2. So I could do f prime. If I get f prime, that's negative 1 over x plus 2 squared. Well, no matter what I plug in here, as long as it's not negative 2, and it won't be because we're plugging in positive numbers, this is negative. Since the derivative is negative, we know it's a decreasing function. So we know that this is satisfied. The other way to do it is to be a little, you have to be a little more specific. You have to say, okay, well, 1 over n plus 1 plus 2, is that less than or equal to 1 over n plus 2? And then you multiply both sides by the denominator. You kind of cross multiply here, and you'd get n plus 2 is less than or equal to n plus 1 plus 2. So n plus 2 is less than or equal to n plus 3. So that's another way to do it. That's a little more what you might call analytical way to do it. This is kind of shorthand. And it's fine. This is a perfectly valid way to do it. But this is, if for those of you who are kind of going to go into a little bit higher maths, do things in what they call the analysis realm, this is a little more like what you could expect to need to do. And then finally, you need to figure out if the limit goes to 0. So I can say, all right, is the limit as n goes to infinity of a sub n equal to 0? And frankly, I should have started here. You should always start with the nth term test for divergence. I don't know why I didn't. I know why I didn't, because I know it's going to converge. Is this true? Well, if I take the limit as n goes to infinity of 1 over n plus 2, clearly that's 0, right? Like clearly. So we know that we've satisfied all three properties. So we know that the sequence converges. Now, in this case, I have negative 1 to the n over pi to the n. Oh, yikes, right? How do I solve that? Well, I need to rewrite this. I need to rewrite this as n equals 1 over pi to the n. Okay. That way, so this tells me this is my a sub n. Now, there's a couple ways we could solve this, but let's start with the nth term test for divergence. Well, as n gets really large, pi squared, pi cubed, pi to the 1,000, that's going to get really large. So 1 over a really large number, drives down to 0. So we're good. Now, we also know that it's always positive because this is a positive number raised to a positive power, so we're always good. Even if it was raised to a negative power, we'd be fine too. Just, it doesn't matter. But when it's a positive number here. Now what we need to do is say, is 1 over pi to the n plus 1 less than or equal to 1 over pi to the n? Well, we can cross multiply here. We get pi to the n. Is that less than or equal to pi to the n plus 1? Well, if we divide both sides by pi to the n, we get 1 is less than or equal to pi. Which of course is true, because pi is 3 point whatever. So that tells me this converges. Now, we worked way harder than we had to here. The reason we worked way harder than we had to here is we didn't have to use alternating series to solve this. So one of the things you could do to self-check is, oh, okay, look at that. I could have rewritten that as n equals 1 to infinity, negative 1 over pi to the n. That's, other than starting at 0, that's a geometric series. So for a geometric series, for negative 1 over pi over n, all we have to do is say, is the absolute value of this less than or equal to 1? Well, yeah, because if this is like 3 point something, 1/3 is less than 1. So we should have known, that converges. It's a geometric series. This is a good example of not working harder than you have to, or it's a good example of if you can prove it right one way, it helps you test the method another way, which is actually the kind of the way I prefer. You know it's true, then you can test the other method. That's really good for real world examples, because in the real world you're going to be trying to do something a new way. Well, test it against the old way that you know works, and then you can test your method. It's regression testing, blah, 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 blah. Anyway, moving along, we have this, negative 1 to the n times 2n plus 2, 7n plus 6. So what we need to do is, all right, I'm going to write this with negative 1 to the n, 2n minus 2, 7n plus 6. So that's my a sub n. So what I need to do now is, first, nth term test for divergence. If you do that, you're going to get 2/7, right? L'Hopital's rule or factoring, I'm sure you can do this by this point. 2/7. That's not 0. So this, my friends, diverges by the nth term test for divergence. So you might ask yourself, well, we didn't test this sequence, we test this sequence. And you're absolutely right, we sure didn't. So what you're going to find in this particular case is if you do it with negative 1 to the n, it's not going to converge to anything actually, because it's going to keep going from 2/7 to negative 2/7, 2/7. Like it's going to be very close to 2/7 and very close to negative 2/7 and very close to 2/7 and very close to negative 2/7. Well, that's also divergent, right? Because it doesn't actually converge to anything. So what you find is if you take off that alternating term and it still doesn't converge to 0, the alternating version is also not going to converge to anything. So it's perfectly fine to just evaluate only the positive part for divergence on the nth term test.